So in this lecture, we're going to really quickly talk about the following important concept known as tension or tension in a rope. Suppose we take some mass, some object, say this box, and we connect a rope or a string to our box. Now let's make the assumption that the mass of the string or the rope is much smaller than the mass of the object. So what will happen when we pull on our string? So if we pull on our string and the force with which we pull is larger than the static friction force, our object will begin to move. But my question is, why is this force that we pull with transmitted through our rope? So let's look at the following situation. So here's our box and we pull with some pulling force. And this creates a tension called the force tension in our rope. So because the string has a very small mass compared to the object's mass, we can neglect the string's mass. In other words, we approximate our mass of the string is approximately 0. And that means our net force on the string is equal to m times a, the mass of the string times the mass or the acceleration of the string, and this equals to 0 because we're making the approximation that our mass is very, very small. So that means that my force with which I pull on the string passes undiminished through the string. And that's exactly why the force with which I pull with is felt by this object as the same exact force. That force does not decrease because the mass of the string is very small. So this pulling force has the same magnitude as the tension force in the string or in the rope, but they have different directions. So I'm pulling this force in this direction, so my net force is going in this direction, but my tension in my string is in this direction because this object is resisting movement.